Hi guys, welcome back to my new video. Now this video we are going to see elementary transformation or elementary operation of a matrix. So this is an left out topic from the previous year syllabus and to this syllabus. Now we will first see what is the definition for elementary transformation. It is the operation that is done on the rows and columns, right? I have given an example matrix. This is an operation done in row and column of matrices to change their shape so that their computations becomes easier, right? They will do certain steps, right? Say for example 5 to 6 steps in order to achieve the result which they need in order to compute the entire sum to the acquired result which we need, right? So this elementary transformation is done in order to get the needed result and make the computations much simpler is what the agenda of elementary operation. Now we will see certain steps that is present in order to continue this elementary operation of a matrix. The first step is interchange of any two rows or two columns. Here the matrix that is given, say for example the 2 by 2 matrix or consider 3 by 3 matrix, the rows and columns are being multiplied. Say for example R2, R2 means row 2, 3R2, this R2 is changed to 3R2 such that the R2 values alone are multiplied with 3. So they will write like this, that is R2 changes to 3R2 such a way that the R2 values that is present in the matrix is being multiplied with 3 and the result matrix will have that values that is been multiplied. The net result which we got after multiplying with 3 will be your next new matrix, so that it will be very helpful for you to achieve your end result. Say for example they are given to find a null matrix or something, a zero matrix. In order to get the values of a11, a12, a13 up to the number of matrix that has been given as 0, you need to multiply the entire matrix with 0. So such way that you cannot multiply directly. So row by row or column by column, everything step by step is what this elementary transformation of a matrix is all about, right? So interchange of any two rows or two columns. So this is again, say for example it is symbolically referred as like this, that is Ri Rj. As per your textbook norms, it is Ri and Rj, where ith row and the jth row. Similarly for this column Ci, Cj, right? So this is the symbolic representation as per discussed in your textbook, right? We will go by that way itself. So again they have given an example. Say for example consider this matrix 1 2 1 minus 1 root 3 1 5 6 7. Now here they have again interchanged the matrix to make the matrix much simpler in order to reach their result much easier. Minus 1 root 3 1 1 5 6 7 2 1. What have they done here, right? This is the starting matrix and they have changed the matrix to like this. Here what happened, right? This 5 6 7 row is as such same in this 5 6 7 row also. Only thing is R2 is went to R1 as well as R1 is going to R2. That's it, right? The R1 value is changed to R2. Simply you can write like this. Either you can write like R1 to R2, right? Either this or this, both means the same, but this is mostly preferred. That is R1 is changed to R2 and this R2 holds the place of R1, right? 1 to 1 is R1, it is changed to 1 to 1 R2. Here this is R2, that is row 2, right? So this is your row 1 to this matrix and this is your row 2 for this matrix and this is your row 1 for this matrix. So this row 1 is changed to row 2 and row 2 is changed to row 1, right? So this is done in order to achieve the result that is asked in your question. So this is interchange of rows or columns. Two rows or two columns. Two rows play a major role in changing their position is what this first point is all about. Now we will see the second point in this elementary transformation. Multiplication of elements of any row or column by a non-zero number. Okay. Now what does this line states? As I discussed before, they would have given one specific matrix value, such say for example in this example they have given 1 2 1 minus 1 root 3 1, but our desired result, let it be like this, right? 1 2 1 by 7. As per the given example itself, we will consider minus 1 root 3 1 by 7, right? This is our desired result and this is what we currently have in our hand. Let consider this situation. We need this as our result. So what we need to do, first see the row wise and column wise, what are the changes that is present in both of the matrix, where the column 3 is totally changed, right? Column 1 and column 2 are same, column 3 is changed. So in order to get this column with this matrix, what we need to do, simply multiply what is needed, right? Simply multiply. Even the value over here is greater than this value, we can multiply by fraction numbers, right? By a non-zero number. That's what is the main agenda, non-zero number. It may be fraction or whatever it is, just a non-zero number, right? Or a whole number also. Over here they are multiplying C3 of this matrix, right? This is C3. What our task is to, we need to get this result, right? This is in hand. Let it be like that, right? For your understanding, this is in hand and this is your result which we need in order to continue our matrix. So multiply this C3 with 1 by 7, right? C3 is changes to 1 by 7 into C3, right? This will be your step. C3 arrow mark, that is C3 changes to 1 by 7 into C3. So when you apply this over here, you get the result as 1, this minus 1, right? This is what we need over here. This is our result, right? So multiplying of elements of any row or column by a non-zero number to achieve our result is another or the second operation that has been given in your elementary transformation. This is generally simple, but when you solve your sums, it will be some more complex, right? So just don't get panic over that. So this is the general explanation of multiplication of elements of any row or column by a non-zero number. Now we will see the third one. The third statement, addition to the elements of any row or column, corresponding elements of any other row or column multiplied by any non-zero number, right? When you study like this, I am damn sure it's not easy to understand, right? I can understand your point of view. Generally, what is this statement discuss? Now, as I told you, this elementary transformation is done to achieve the desired matrix which we need in order to combine our result, right, at last. Now the first two steps is just change the rows and columns, multiplication of row and column by non-zero number to get the result, etc. Okay, fine. Now this third step plays a major role in elementary transformation and which is frequently done so that you can achieve your result more easily. How it is done in your textbook, the given example you just see, you just don't need to study the entire the stories that has been put up. Just see what is the main example that is given, R2 minus 2 R1. The matrix is 1 2 minus 1 2. Okay, consider this, right? So split up, this is R1 R2. What they have given is R2 is, see, R2 arrow mark means this R2 is going to undergo certain operation, right? This is for this elementary transformation. This R2 is going to undergo certain operation. Okay, what is that operation? Operation is all about, right? This R2 minus 2 times of R1. Okay, fine. So the matrix, the net result matrix, when you apply this over here is, see, first R1 1 2, you just need to write, because the R2 is what going to undergo an operation where R1 is undisturbed, right? So just write R1 as it is. What happens to R2? R2 2, right? 2 minus 2 times r1, 2 times r1 of this with respect to the position of first element of r2. R2 first element respective position to r1 is 1. 2 into 1. See, this is 2. Respective position of r1 is 1. This is minus 1 of r2. Respective position is 2 in r1, right? So 2 minus 2, so 0. Similarly, for minus 1, so minus 1 minus 2 into 2. So that gives you minus 5. So this is your new R2, right? This is your new R2. Okay, after this again repeat some, like this R2 is R2 minus 2R1. Similarly, some other thing in order to achieve your result that has been asked in your question, right? So this is generally an example, right? Or the what I told you, this is the general steps or formulas that has been followed in your elementary transformation. So after this same procedure can be repeated in any types, right, or in any computation or in any combination, so that you can achieve your result easily with certain small number of steps, right? The more you do like this complex, the less number of steps it comes, right? So this is your third operation or the transformation elementary that is given in your matrix. Now we will see what is the invertible matrices. So as per the definition that is given in your textbook, if A is a square matrix of order m, and if there exists another square matrix B of same order m such that AB equal to BA, that is equal to 1, then B is called the inverse matrix of A, right? Invertible matrix is also known as inverse matrix. So consider this matrix, that is A. Invertible matrix of A will be represented as A inverse, right? So as per the given example in your textbook, 2 3 1 2. Similarly, B equal to 2 minus 1 minus 3 2. Only the sign change differs the matrix, that is A and matrix B, but if the sign is same, both the matrix are equal, right? Generally, just for understanding, I'm just telling you. Now as per the rule, multiply this both, that is 2 1 2 3. The numbers place here the same rule, but only thing is sign is being changed to this, right? But they are. So when you multiply this, you get the value 1010. That is equal to, when you take a determinant value, you get it as 1. That is modulus of AB, right? So you get it as 1. Similarly, BA. What happens when you do BA? That is 2 minus 1, 2 minus 3, 2, right? Interchanging of the matrix value, as we have seen in the previous videos. When you find AB, you get certain value. When you find BA, chances of getting another value is more, right? There is less number of chances that is present when you get AB and BA value to be same. Over here we get the same value, that is 1. You just multiply and see, you get the value 1. So therefore B is inverse of A to A inverse. B is inverse of A. Our aim is nothing but we need to find the inverse, right? So AB equal to 1. Similarly, we got the value BA to be 1. Therefore, B is inverse of A. So therefore, B equal to A inverse. So A is inverse of B. Both are same, right? A is inverse of B. So A equal to B inverse. Both are same, right? When you just crisscross, as because you got the value of AB to be 1 and BA to be 1, when you find the value of A, that is nothing but B inverse, you can just generally inverse the B value. If you want to find the value of B, you can generally inverse the A value, right? You get the same result. So that is the invertible matrix definition, right? So in the next video we can see the examples and the theorems that is present in the elementary transform. Again, this elementary transformation, find the inverse of the matrix, is very important question in this matrix lesson. The next video we can discuss from example 23 and upcoming exercise that is present in your textbook. So thank you guys.